How is everyone this morning?
Pretty good, Zico.
Good. How is this quarter going for you so far?
Pretty good, I think.
Good. How about the rest of you?
It's going pretty okay.
Okay. You miss being on campus?
Yeah.
Okay. Who said that, Joey?
Yeah. Helped keep me accountable and more on task.
Okay.
I could agree with that.
Yep. It's mixed bag. It has its pluses and minuses. I think we're all going a bit stir crazy, spending so much time at home. Every time I get into my car, I feel like I've never driven this thing before because I only do that maybe once a week instead of multiple times a day. All right, it's 10 o'clock. Let's go ahead and get started. Good morning, everybody. I'm recording this just to show you where we are and what's the plan for today and next week. So we've completed chapter 1, 2, and 3. I'm sure you remember 3 was about authentication, authorization, and accounting. Nothing new, we just elevated it to the enterprise level. And today we're going to cover not all, but maybe 2/3 of chapter 4. And then on Tuesday, next week, we're gonna finish chapter 4, and then we're gonna finish chapter 5 as well. So I don't think we're gonna have a whole lot of new material next week. Well, actually, it is a new material, but not a lot of new material, because what we're not doing on firewalls today is ZPF, and we'll talk about it on Monday, and this is going to be a new concept for you. And then chapter 5 is intrusion detection and intrusion prevention, and I'm going to assume it's going to be new to most of you, and however, packet tracer is quite limited. So we can talk about it and make sure you understand it. I'll make sure you can answer those interview questions well and correctly. And we'll do whatever labs we can do with packet tracer, but it's quite limited. But hopefully enough that you understand what IPS is. And that's the plan for today and next week. And then we come back. Chapter 6 is very rich and very, very good. And we will wait until week 5 for that. So this is the plan. So a lot of the first part of chapter 4 is a review, because we've been talking about firewalls for a while, and we're going to be talking more about them in chapter 4, but a sizable chunk of it is a review. So let's go ahead and get into the slides. Any questions on chapter 3 before we move on to chapter 4? Okay, then let's close and dive into chapter 4, firewalls. Okay, so we've been talking about firewalls for a while here. Firewalls are very, very important. Firewall is an extremely important security tool, but shouldn't be the only tool. And you will hear this from everybody, and you will see this over and over again. And I really want you to internalize it. So your home wireless access point has a stateful firewall installed on it. It's enabled by default, and by default, you can go wherever you want. No one can come in from the outside, and that's good. That's what you want. And it provides a very important security measure, but shouldn't be the only one. We still have a need for anti-malware. We still have a need for secure passwords. We still have to protect ourselves against brute force attacks, etc., etc. So you can see, it's a very, very important tool, but shouldn't be the only tool. And if it's the only tool, then you're asking for trouble, because you can block everyone from coming in, but that doesn't mean you're not going to be going to some website and doing something. Okay. So we'll start here, and this is definitely a review, and please ask. So if you remember, when we started talking about firewalls and ACLs, we started with standard numbered. That was the very early, this is version 1.0. This is ACL version 1.0. And if you remember, the only thing we can block is the source IP address or IP addresses. And it's quite limited, but we have to start somewhere. And then later on, they added a named, standard. Okay, very good. Instead of using a number, we can use a name. And then version 2.0 was extended. Okay, so they said, standard is very, very limited. It has too many limitations. The only thing you can do is you can act on a source IP. That's not nearly good enough. So they invented standard version 2.0, and standard gave us a lot more flexibility. We can permit or deny, which is filter, based on a source and destination IPs. We can filter based on a protocol, IP, TCP, UDP, ICMP, and I can go on, okay? And we can also filter based on a port, source and destination port. And by now you all know that almost all of the protocols use an ephemeral port number for the source port number. So this is not something we really want to use very often, because it's ephemeral and we don't know what it is. But the destination port is very, very important, and that's usually what we filter on. So extended was a giant step forward. And let me see. And then we have the ACL, and then we have the ACE, and I think we're all very comfortable with this terminology by now. The ACL is the access control list, and the ACE is the access control entry, and an access control list can consist of multiple entries, okay? And this is what the syntax looks like. And coming back to the extended, do you guys remember this established? Okay, so we can filter, permit, deny based on source destination IP, protocol, source destination, port numbers. I already talked about the uniqueness of the source port number, and then established. So let me ask you a question. Does anyone remember what established is? What does it do if you choose to use it?
If you reach out through a port and create a connection, traffic is able to come back through that port.
Very good. Excellent, Joey. Nice job. Okay. And this is useful. This is very, very useful. You don't want anything coming in, but you want to allow what was initiated internally to come back in. And you can do that with established. And later on, when we get into the labs, we can certainly do a lab with established. So let me move forward. So far, nothing new. I hope so far, nothing new. Okay. So some examples here. Access list, standard, no access, deny host. So this is a standard, and we're denying this one host. Very good, but this is very, very limited. Okay, and like I said, with standard access control list, all we can do is act on the source IP or IP range. Down here is, this is extended. You can see that it says extended, permit TCP. And give me a second, I do want to open up my table, because we can talk about ACLs without a table. Let me minimize this. And here it is. Okay. So these are the protocols we talk about. So if you were to enable IP, you're enabling IP and anything above IP. So automatically you're enabling all TCP and all UDP. Please remember this, everybody. And you cannot use IP and specify a port, because down here, we don't have ports. We have IP addresses. Or if you want, you can filter on TCP, you can filter on UDP, you can filter on ICMP. I just wanted to make sure that you understand the hierarchy, and that when you see IP, not only you're talking IP, but you're talking everything that sits in the top of IP. So remember this and you will be fine. And you cannot use IP and a port number, because port numbers don't go with this layer 3. Okay, so back here, you know, permit TCP, okay, and here we have a range of IPs. So basically the entire class C subnet equal 80 equal 443, and I think we all know what that is. Allow HTTP and HTTPS, and this is an example of established everybody. So if I initiated it internally, I want to be able to come back in. And of course, the last statement in every ACL is a deny any. So if you say permit one line, very good. This is what you have specified explicitly. Implicitly, right below it, you have deny any. And that's true for all ACLs. So to come back to this ACL over here, it does explicitly permit TCP any, okay, established. And it didn't say it, but it's there. You could explicitly put it in there if you like, or you can leave it out, but it's there. And that is the implicit deny any. Okay. This is probably one of my favorite slides. And if you understand this slide, you're in a good shape. And if not, then roll up your sleeves and become comfortable with it. But this is a very important slide. So the first line is create an ACL globally and then apply it. Okay, very good. Ensure the last statement is an implicit deny any. You don't really have to ensure, it is. Could everybody ensure or not? It's there. That is the very last statement, is an implicit deny any. Remember that the statement order is extremely important. So this is one thing you don't want to forget, the order. Not that you have all the stuff in there, it has to be in the right order. Because if your very first statement is deny any, then it doesn't really matter what you have after that, because it's going to deny and you're done. So you're not going to process all of the ACEs. You're going to keep going until you hit a deny or a permit, and then you're done processing. And the opposite is true. If you were to say permit any, if you start with permit IP any, then it doesn't really matter what you have after that. You're never going to get there, because that's going to give that computer permission to do what it needs to do. So the order is super important. And if you have an existing ACL and then you want to add something, then you have to be really careful that it's being added in the proper order. Okay. Ensure that the most specific statements are at the top. So if you want to allow one device, well, you do that first, okay, before you deny. Or the opposite is true. If you want to deny, you know, a device or devices, you put that in the top before you permit any. Yep. Remember that new statements for an existing ACLs are added at the bottom by default, unless you know you use the numbering scheme for that access control list. Okay. Remember that routers generated packets are not filtered. This is a lot of people forget this, that you know the packets that are being generated by the router itself are not going through the ACL. Okay. And place standard ACLs close to the destination. Okay. Because you're filtering on the source, and if you were to put that ACL close to the source, then that source won't be able to do much. And then the opposite is true for extended, because we can filter on source and destination, and it says, you know, place extended ACLs as close to the source as possible. Very good, because we don't want the traffic to go all the way across the network and then drop it. That doesn't make any sense. Drop it as early as you can. We couldn't do that with standard, because we would be prohibiting that device from communicating. We certainly can't do it with extended. There's absolutely nothing new so far. This is a review. It's an important review, but it's a review. Any questions? Anybody? Okay, let's move on. I will get to the labs. We will do labs. Okay. So you can do show access list. Now you can see the numbers, everybody. And if you were to add a new ACE, it's going to be added to the end. And if that's not what you want, then you know you can certainly you know, delete a specific ACE or add an ACE in the right place. I hate doing this. I have to tell you, this is just me. This is my style. I go back to the original ACL I change it, and then I apply the entire ACL. So as a rule of thumb, you know, I don't really want to be modifying an ACL in RAM. Okay, you can, and this is showing you how to do it. I just hate doing anything straight in RAM. I would much rather go back to my configuration file, fix the ACL, and then apply it. And then it's gonna work fine. And I don't have to say, okay, you know, how do I delete this line and how do I add a line between these two lines? Okay.
Now, when you say you're to do that, are you saying like you have your ACL like in a notepad, you have the entire command set out, you edit what you want in, you go in, you delete it on the router, and then you copy paste right in, and that way it's only a split-second loss?
You got it. You got it, Frank. Okay. And for me, to begin with, all of your configurations should be in a configuration file, right? Everybody, I hope by now I've taught you this is a no-brainer. Okay. They have to be in a configuration file for backup purposes and plenty of other purposes. So you have to fix the configuration file. So fix the configuration file and then reapply. Not necessarily the entire configuration file, just that one ACL. But you have to fix your configuration file. Good. And if you don't have a configuration file, then you're asking for trouble. And I don't want to spend time talking about that. You have to have configuration files because you don't want to rely on what's in RAM. Because what's going to happen when you reboot that router? Or what happens if you want to replace that router with a different router, a newer router? Then what? You're going to sit there and type everything one more time. So I hope you've learned that lesson, and we don't need to spend time talking about it. Okay. All right. So anti-spoofing. So let's talk about spoofing a little bit. Oftentimes, what the unethical hacker will do is they will use a different source IP address from their IP address because they don't really want the traffic to come back to them. They want the traffic to go somewhere else. And this is an ACL to address that one problem. And I want you to know I stared at this slide for maybe 10 minutes before I found out the first line is incorrect. It is a typo. Because right now it's saying deny everything. And I'm saying, okay, if you're going to deny everything, then what's the point in having all that stuff below? Making sense, everybody? And then it hit me, okay, it's a typo. What they really meant to say is deny IP host 000. So if someone used an IP address of 0000, we're saying deny that. We don't want to deny everything. And then 10 is private, class A. 127 is a loopback. 172.16 is private, class B. 192 is private, class C. 224 is a multicast. And then the very last one is a broadcast. So we're basically saying those IPs don't belong in the source IP address, especially going over the internet. Does this make sense, everybody? Do you see why you want to prevent these source IP address? And we're saying if this is the source IP address, then most likely it's been spoofed, the IP address, and it's some kind of an attack that we just want to drop. Any questions on this? Can you see the error in the first line?
I don't think I can specifically see it. I see it now that you have the note up there, but
okay.
I wouldn't have caught it. No.
Okay. I stared at it for 10 minutes saying, okay, what are they trying to say? And then it hit me. It's like, okay, it's a typo because
I have the NetLab open. NetLab actually has that now that I look over there.
Okay. Oh, very good. So they fixed it in the NetLab.
Yes.
I'm glad to see. Okay. They just haven't fixed it in the slides. Okay, well, that wasn't really a waste of time. I never, ever look at these things and say, gee, that was a waste of 10 minutes. That was a good troubleshooting 10 minutes for me. And it took me 10, 15 minutes to figure it, but I did figure it. Okay. So permit necessary traffic through a firewall. So we have a user and they have a router that gives them access to the internet. And UDP, everybody, you see this doesn't say IP, Because if it said IP, then that includes TCP and UDP. It said UDP, and because we said UDP or because we said TCP, now we can use port numbers. So we can only use port numbers with TCP, UDP. So UDP domain is a DNS, and DNS uses UDP. So we're enabling DNS. We're enabling send mail. SMTP is when you're sending mail. We're enabling FTP. We're enabling Telnet. We're enabling syslog, and we're enabling SNMP trap. Now there's a lot of stuff missing here. I'm saying, where is HTTP? Where is HTTPS? And where is ICMP or POP3? And these are the protocols that we use to retrieve our mail, but it doesn't have to make sense. It's technically correct. So we're saying this is the stuff we're allowing this user to do. And if you were to take a closer look at the domain, we're saying any from the inside only to this DNS, okay? And TCP, any host only to this server. So this is very smart. So we're saying anyone from the inside, but you can only use this DNS. You couldn't use 8888, which is the Google DNS, but you can use this one DNS. And if that's what we wanted, great. Then this is a good ACL. Okay. ICMP, okay, of course, ping uses ICMP, and down here it says permit, and this is inbound. And let's talk about inbound and outbound, everybody. So this is inbound into S000, and this is outbound from S000. And this is inbound into gig 00, and this is outbound from gig 00. Make sense, everybody? So it's always from the router point of view. Inbound and outbound is from the router point of view. It's not from the user. It's not from the device. It's from the router device, but not the server, not the PC, not the user, from the router. So we're saying allow echo reply. So we have echo request, which is the ping, and echo reply, which basically means allow a reply, an echo reply. Anyone remember source quench? This is an ICMP. Let me show you something. So we're going to come here, and we're going to do ICMP wiki. And scroll down, and there are lots of things you can do with ICMP. So echo request, you're pinging. Can I ping? Yes, you can ping. Destination unreachable, and we have lots of different destination. What is unreachable? The network is unreachable, the host is unreachable, the protocol is unreachable. And then source quench, and it says congestion control, which basically means slow down. Okay, I'm gonna permit it, but just slow down. You're overwhelming me. And sometimes they use ping for a denial of service attack. And this is one way of saying slow down. And I'm not gonna go, here we go, echo request. Okay, and this is the ping itself. Am I allowed to ping? Can I let a ping? Can I allow a ping reply back? And it's a long list, and I'm not gonna go over this list, but make a note. Okay, make a note, write down, ICMP wiki, and take a few minutes and look at it, because you will see these ACEs often dealing with ICMP. And ICMP isn't only used with ping. It's also used to communicate error messages, and it's used to communicate between the different devices. So we want to allow a reply. We want to say slow down if we're getting congested. I would like to know what is unreachable. And there's a bunch of other parameters, and you can look them up in the ICMP wiki table we're looking at a minute ago. No SNMP server, you don't want to enable SNMP, and V6. So before we get to V6, let's do some V4 labs. So any questions from the slides? So this is the logic. And now we get to do some labs to reinforce that. You're good? Okay.
Yep.
let's do some labs. So just watch me and we'll do this together. So 285, packet tracer. I just finished the labs for chapter 5, which we'll do a week from today. And I have to say, you know, I'm having a miserable time finding out what packet tracer can support from an IPS point of view. So far I've found one rule and I'm desperately looking for a second rule. So we have one rule, so we can do a good lab with it, but I'm trying to find a second rule that packet tracer supports. So let's come to chapter 4. And the first 2 labs we've done before. So you tell me if you want me to go faster or slower here. But I want you to understand. I just don't want to spend half an hour with each of these labs because we've done them before. So if you've taken courses with me before, you've seen these before. And I don't think I've made any changes to them. Here it is. Okay, so this is standard. Remember, standard was version 1.0, extended version 2.0, named extended is version 3.0, and this is the only thing IPv6 uses, because IPv6 came so much later than IPv4. They said, you know, we don't really want to, backward compatibility is not important for IPv6 because it's brand new. And they said, let's not do standard and extended, we're just going to have the equivalent of extended, and let's not do numbered and named, we're just going to do named. And that's all that's available for v6, and we'll talk about v6. Okay, so all the routers are configured with OSPF. Standard ACLs filter packets based on the source IP address only, not source destination, no protocols, no ports. Source IP addresses. And by now you all know that the last ACE in the ACL is always a implicit deny any. Whether you put it in there or not, it's there. So we want to create an ACL to prevent the troublemakers PCs, here they are in red, okay, from accessing payroll and engineering. This is the we want to payroll engineering. Do you see payroll and engineering? Troublemakers. Okay, so we will see. We will go by the IP addresses. Okay, and I start by making it incorrect, and then we work our way toward that. Okay, so what we want to do here is we want to prevent them from accessing the FTP server, and we want to prevent them from accessing the web server. So we want to give them access. We just don't want to give them access to this FTP service on this server, and we don't want to give them HTTP, HTTPS access to this server right here. But they can use everything else. So these are like the secure services we want to protect. They can use everything else. Okay, very good. So you tell me what's wrong with these ACLs, and if you want, we can apply them and see. So prevent troublemakers from accessing payroll and engineering, access list 1, deny any. And then we apply it. This is gig 00, everybody. This is gig 00 right here. On which? On router 1. This is router 2, router 1. Okay, so we apply it to the gig 00 interface on router 1. What's wrong with this ACE? I'm trying to engage you here. It's a terrible ACE. What's wrong with it? Look, everybody, deny any. We're not allowing anybody access to this entire subnet, and they can still access the web server on the other subnet. So clearly this is wrong. And remember, we wanted to prevent these troublemakers from FTPing to this server. We're not saying you can't use HTTP on this server, you just can't use FTP. Nor are we saying you can't use FTP on this server, you just can't use HTTP. So by blocking them access to an entire LAN, that doesn't really solve the problem. It just blocks access to this entire local area network, and that's clearly not what we wanted. Do you want to see it, or do you want me to move forward?
We can move forward.
Okay, thank you. So let's move to scenario 2. So scenario 2 is access list 1, deny 192.1. Okay, very good. So we're saying deny 192.170.2 subnet. And this is the subnet the troublemakers are on, right, everybody? So we're saying deny this subnet and gig 00 out. Okay. So now we're not denying everybody, because before it was deny any. So we're denying everybody access to this one subnet. And now we're saying, no, we don't want to deny everyone access to this one subnet. We just want to deny this class C subnet access to this subnet. What's wrong with this, ACL?
You're only denying that specific, so anything else would be able to come through. Right.
Which is fine, because we're just trying to prevent those two troublemakers from having FTP access to this machine and HTTP access to this machine. Go ahead.
I think it's the direction.
No, there's nothing wrong with the direction. There's nothing wrong with the direction. You can do it at in, and you can do it at out. It's not so much the direction. I want to bring your attention to this third PC on this 192.170.2.0 subnet. This is an innocent standbyer that happened to be on that one subnet, and we're penalizing them for being on that subnet because we said block the entire class C subnet, right, everybody? And this guy is saying, I'm not a troublemaker. Why can't I get to that remote subnet? B, we're preventing access to the entire subnet when all we wanted to do is prevent access to the FTP service on this one machine on that subnet. So it's just way too broad. And C, we're not doing anything about HTTP on this server on this other subnet. Okay, so it doesn't get us to where we want, because we're preventing everyone from this class C subnet to access this entire subnet over here. And we're not protecting the HTTP service on this second subnet. So if you want to see any of this, do let me know. But you have the labs, and I encourage you to walk through them and make sense. The reason I'm saying this is wrong, because it's going to help you understand why it's wrong, and that will solidify your knowledge. Okay, I'm going to move forward. Okay, take 3. Okay, and now we've added these 2 interfaces on router 1, which is good, because we have one service on one subnet and another service on another subnet. And I'm still saying, deny 192.170.20/24, deny this entire class C subnet access to these 2 subnets over here. 2 problems. Problem number 1, this standbyer over here, this person is not a troublemaker, and they're being penalized for being in the same subnet with the troublemakers. B, we're preventing access to the entire subnet when we only wanted to prevent FTP and HTTP access. Does that make sense?
Yeah, so don't you just want to block any HTTP traffic from that subnet then? Wouldn't that be better?
Well, not only do we want to prevent FTP access from the subnet, we only wanted to prevent it to these 2 specific machines. Okay. And just to jump a little bit ahead, we can't really accomplish this using standard, because standard we can only filter based on a source IP, right, everybody? So we can't say, yes, you have access to the machine, but you don't have access to the FTP service. We can't using a standard ACL. And we can't say, yes, you have access to this machine, but you don't have access to HTTP service on this one machine. Standard doesn't give us that granularity. Standard is, block the source IP. I'm done. Version 1.0. So I'm showing you the problem with standard is oftentimes it doesn't work because it's very, very limited. All we can do is prevent the source IP from accessing a machine or a subnet. But we cannot use it to prevent a specific protocol or a service. That requires extended. So this is the problem here. Let's see, is there for? Very good. So we got a little smarter with take 4. And I said, okay, this third PC on the troublemakers subnet, so we're gonna let them do whatever they want. So now I'm only preventing 192.170.2.2 and 2.3, the troublemakers. Okay, so not the entire subnet like we were doing before, the troublemakers. And I'm applying it to these 2 destination subnets. Okay, this is better. We're moving in the right direction, but it's still not what we want, because what we wanted is to prevent FTP and HTTP. And there's no way you can do that with standard ACL. Is there a take 5? Okay. And take 5, instead of using a numbered standard, we're using a name standard. So that's really the only difference between take 4 and take 5, is I'm showing you how to use a named ACL instead of a numbered ACL. If you remember before, it was access control list 1, and now it's access list deny crackers. Okay, good. A name is more meaningful than a number, but it's not going to change the nature of a standard ACL. Are we good? So we can't really accomplish this goal with a standard. We can get closer and closer to the goal, but we can't accomplish the goal because standard doesn't give us that granularity. We could certainly say prevent those 2 troublemaker PCs from using these 2 destination. No, actually, we can't even say destination. We can just say source. We can only block on source. So we can block them at an interface level. So you pick an interface, and that's as close as we can, right here. This is as close as we can get. We can prevent those 2 source IPs from accessing those 2 remote subnets. And that's not what we wanted. Questions? I know there's lots of details in ACLs, but you have to conquer ACLs. There's nothing really hard. It's just lots of details. And the more time you spend with ACLs, the more sense they will begin to make. But this is one technology, everybody. And sorry for interrupting you, Frank. This is one technology you have to conquer, because you're going to have to deal with ACLs, and maybe not the ACLs you're creating, someone else has created, but you still have to understand, you know, what they did and why it's not working, And if you're asked to tweak it or fix it, you have to understand what it's doing before you can fix it or tweak it. So this is one technology you have to conquer. And ACLs are super popular. I mean, firewalls everywhere. Your computer has a firewall. Your wireless access point has a firewall, and then you connect on ISP router, which has a firewall. And by the time you get to Google and come back, you've gone through God knows how many different firewalls. And any one of those firewalls can block you. So we have to conquer firewalls, or you won't be able to do your job. Frank.
I was just going to say ACLs is one of the areas that I feel is like one of my weakest. So this just reinforces I need to go back through and go back to the previous courses and redo some of those labs and get better practice at it. Because I really do feel rusty at this as we look at it.
Good. And thank you for your honesty, Frank. And start here, Frank. Start with this lab. So you can go back, but start with this lab. You really don't need to go back because the slides we've gone over at the beginning of today's lecture, that's it. That is the review. Everything we've done so far today is a review. There is absolutely nothing new. And there's nothing new until the end of this chapter, when we start talking about ZPF. And if you don't understand ACLs, ZPF is going to be a waste of your time. So we have to conquer this before we can move to more advanced firewall technologies. Yes, Cody.
I was just going to ask really quick. This may be a silly question, but is it better to have separate ACLs per, I guess, application or scenario, or just have one ACL per interface with all of your statements?
Do you remember? Let's go back to the golden rules, everybody, because, and I hear your question, Cody, and usually I would say, you know, have multiple ACLs. That's usually what I would say, is have multiple ACLs. That way you're not mixing oranges and bananas and eggs all together. But if we are to go back to the golden rule, one ACL, okay, per interface, per direction. Do you guys remember that? One ACL per interface, per direction. So you're limited to one ACL per interface, per direction. So you can have two ACLs for that one interface in the same direction. You can have one in, one out, but you can't have two in and you can't have two out.
Okay, very good, very good.
So that answers the question. So sometimes they have to get more complicated than you really would like them to, because, you know, you can only have one ACL per interface, per direction.
Okay, that's what I thought.
Yeah. So let's move to extended. Okay, so it's really good to start with standard. You want to understand standard because maybe they're still using standard, and standard is so much easier than extended because the only thing you can filter on everybody is the source IP. Okay, it's not complicated. That's it. You can only filter in the source IP. Extended, source, destination, protocol, and source destination ports. So it gives you a lot of flexibility. So let's start with lab 2, and maybe I want actually to do these labs. So let me go ahead and open up 2. And if you have questions, ask. And Frank, I really do appreciate your honesty. And I know this is challenging and somewhat confusing for many people. And you just have to conquer it. You just have to take my word for it. You have to conquer firewalls. And I don't know if this is our second attempt or third attempt over the previous courses, but this is, if you've taken, you know, CIS 151, 2, 3, 4, and now you're taking 285, this is our third attempt at ACLs. Go ahead, Joey.
Does the golden rules for one ACL per interface protocol and direction also apply to ISAs like hardware firewalls?
I'm thinking, Joey. I believe this is the case, Joey. Now, you may have a GUI that is hiding the complexity. So if you have a GUI, the GUI is going to hide the complexity, but at the very end of the day, this GUI has to convert all that GUI stuff into an ACL, and then the golden rule will apply. Am I making sense? So I want to show you something. Stay with me for a second. So we all have a very fancy stateful firewall on our PC. So I'm going to show it to you really quick, and we'll come back here later. So this is on my PC, your PC. And they have 3 different interfaces for this one firewall. They have an interface for the masses, the people that don't really understand firewalls. And all they can do is just block, which is fine. That's good enough. And then they have a GUI for the somewhat technical. And this is allow apps or features access. So you don't really understand ACLs, you don't understand ports, but you say, I want to allow permission to be able to do an RDP, a remote desktop connection to my PC. And you don't have to deal with the port numbers. You can just select the application. And then they have an advanced feature. And I'm showing it to you. And we have inbound and we have outbound rules. So let's click on inbound. Okay. And all you have to deal with is this GUI. So it hides a lot of the complexity in the background. Okay, you don't really have to deal with the ACLs and ACEs and inbound and outbound and all that technical stuff. But they're giving you a lot of granularity here. This is a very, very powerful firewall with a lot of granularity, but they're hiding the technical stuff from you. All you have to do is just say, I want to enable this, I want to disable this, and then something happens in the background that applies it to an inbound or an outbound interface. Okay. I'm going to go back to my lab. We may come back here later. Okay. To be more surgical and to deny access to specific IP and or specific service port, extended ACLs are required because standard can only filter based on the source IP. So if you want to do anything more, like a destination IP, like a protocol, like a destination port number, then we have to use extended. And this is the format, okay, access list. So we have to use 100 through 199. So if you're using numbered ACLs, 1 through 99 for standard, 100 to 199 for extended. If you're using named ACL, then we don't use numbered, and that's probably what you want to do moving forward. Permit deny protocol. So remember, you can permit or deny using a protocol. And I said IP includes TCP and UDP, anything basically above it. Okay. Or you can be more surgical and say TCP, UDP, ICMP, GRE. It's a long list. Source and destination IP addresses or IP address ranges. So it can be just a single host or an entire subnet. And then a port number. You can actually filter on source and destination. Almost always we filter on a destination port number because those are the services, the well-known port numbers we're all familiar with. And we already talked about established. And if you want to log, you can just put log at the end, and then it's going to log the event. And the default log is the console. So if you don't have a log file, it's just going to show up on the monitor on your console. Okay. Extended ACLs filter based on protocol, source and destination IP and or source and destination port numbers. And of course, the last statement is an implicit deny. Whether you put it or not, the very last statement is always deny any. Okay. So the mission is the same. So this is the same packet tracer lab. We still want to prevent those two troublemakers, 2.2 and 2.3, from accessing this secure FTP service on this one computer. We don't want to deny access to the entire computer. We just want to deny access to the FTP service. And we don't want to deny access to this entire second server. We only want to deny web access to the server. Okay, so let's take a look. And you tell me if this is going to work or not. Okay, so access list 101, the number is important. Okay, deny IP host and host. So I am saying deny source, okay, from 2.2, from the first troublemaker to this FTP server, and IP host 2.2 to this server. So I have 4 statements. So for the first troublemaker, PC deny access to the 2 servers, and then for the second troublemaker PC, deny access to the same 2 servers. Okay, and then permit any. And you can see the more restrictive is first, and then permit IP any. And yes, I still have implicit deny any, but it doesn't really matter because the permit IP any is going to permit everybody, right? Everybody. So I don't think that's going to be very useful, the implicit deny, because we have an explicit permit any just above it. So you guys tell me, is this going to work?
It'll work for those 2, but obviously anything else, if those aren't static IPs, then
okay. But here they are static IPs. But I want to bring your attention to the service. Okay, so we're denying access to the entire server. We're not denying service to the FTP server. We're not denying service to the HTTP server. Do you see that, Frank? So we're saying you can't access those two servers. Very good. Well, this is again getting us closer, but that's not what we wanted. We just want to deny them FTP. We want to deny them web. And then let's look at the interfaces. Interface gig 01. This is 01 right here. And in, okay, very good. This is coming in. IP, no. I'm putting it right here. Sorry, this is in router 2. This is in router 2. Very good. Okay, and it applies. So I want to do it. So let's go ahead and copy and paste. So I'm going to copy this. And I'm going to put it on R2. And I strongly recommend you do this on your own. And show access, show access. And this is my access list, exactly as I typed it over here. And I can do show run, and you will see it in show run as well. So this is the ACL. And if I was to go back to gig 01, and you can see I applied it to this interface. Okay, IP access group 101 in. And in makes sense because into the router, into, and we want to deny or permit as early as possible, and you couldn't deny or permit any sooner than that. So as soon as you come into the router, make that decision. Okay, so let's go into simulation. Let's go and see if this third PC on the same subnet with the troublemakers can do whatever it wants. So from here, we didn't prevent this computer from doing anything. So ping, let's do FTP. FTP 192.168.1.3. This is the FTP server. Yep, they can get to it. That's wonderful. Can they HTTP to the web server? 192.168.2.3. Yep, very good. So let's go to troublemaker number 1. Okay. Can they FTP to the first server? 192.168.1.3, and it should fail. How about if I type the command FTP? Okay, and it's being blocked, and I can show you in the simulation right here. Okay, and that's what the ACL did. Well, what if I wanted to use the HTTP service on the same server? So that should work, right, everybody? Because I only wanted to deny it FTP. So if I was to come over here and type 192.168.1.3, okay, and this is not working. It's not working because I denied those two troublemakers any access to these two servers. And that's not what we wanted. We only wanted to deny FTP and web. So much better off than we were with standard, but still, you know, we're denying them access to other services that they should have access to. We wanted to be surgical and just deny those two services. So let's do the second try. Okay. So let's take a closer look at take number 2, everybody. Okay. So let's go over it together. Deny the first troublemaker host equal FTP. Okay. So I'm not saying, you know, you can't access this server, and you can see I'm using TCP here, not IP. Before it was IP, and TCP and UDP sit in the top of IP. Here I'm being much more surgical. I know FTP and HTTP are TCP-based protocols. So I'm saying deny TCP only for FTP, and deny port 80. And I could have said web. Web is the same thing as port 80. And deny port 443. Okay. So I'm denying it FTP, I'm denying it HTTP, and I'm denying it HTTPS. So this is the surgical, this is very good, but that's not what I wanted, because I didn't really want to deny HTTP access to this server, only FTP. nor did I want to deny FTP access to the second server, only HTTP. But still, this is going to put me a lot closer than I was before. So let me do this and try it. And you can delete the ACL, or you can just restart the lab. So let's copy and paste. Do you guys see how this has got us closer, but not exactly to what we want? So I will show you. Okay, these two were unnecessary. Okay, and then this was unnecessary. So let me copy and paste. And paste. Show access. Okay, here it is. And let's see if ping is going to work. So I'm going to come over here and I'm going to ping 192.168.1.3. And let's see if that's working. Okay, so I can get to it, which is good. And I can do the same thing to the other server, 2.3. Very good. Okay, let's see if I can FTP from the troublemaker PC. So can I FTP to 192.168.1.3? And this should fail. It's going to time out. And let me see if I can HTTP or HTTPS and 192.168.1.3. Okay. Which is good. That's what I wanted. Did I paste the wrong thing? Oh, you guys weren't reading with me. Okay. So let's read this carefully. Okay. Host 22, very good. So we want to deny this. The second one is 22 to this, and that's something we wanted. So we wanted to provide HTTP access to 2.3. Okay, 2.3. So this is fine, everybody. This is fine. And then I'm doing the same thing for the second troublemaker PC. Okay, so this is a perfectly good ACL. Okay, so I'm sorry. This is a perfectly good ACL. I just wasn't reading the IPs carefully enough. And that's exactly what we wanted. We wanted each of those two computers to have FTP access to one and to deny FTP access to one and to deny web to the other. And this is what we did. So from here, okay, I can do a web access to 192.168.1.3. Okay, and then from here, okay, I shouldn't have web access to 2.3. So 2.3, this should fail, 192.168.2.3. Okay, so it's failing. However, I can do FTP access to 2.3. So FTP 192.168.2.3, and this works. Because all we wanted to do is deny FTP to this and HTTP to this. And this is very precise. And this is the beauty of an extended ACL. It gives you the granularity you want, to be as surgical as you want. Questions? And I think the next one is just named. Yep. So the only difference between take 2 and take 3 is instead of numbering it 101, I named it deny cracker. before. The stuff we've done before makes sense.
I think Zoom's having
Questions?
a problem. Everything just like went to Decepticon voice. I'm not sure what you said.
Oh, that wasn't
Okay.
just me. I've been having Zoom problems all day. I've been like crashing 6 to 7 times already. So I
Oh,
don't know if
really?
it's just me having
Okay.
problems or not.
I'm sorry about that. You do have the labs. So
Yeah.
if you can hear me, you do have the labs. And like all labs, this is true for every single lab we do is, I hope you're doing them on your own and going at your own speed and making sure
I'm
they're
just glad you're
making sense to
recording them.
you.
I'm glad you're recording them because I'm definitely going to go back.
Okay. Okay,
It's just
good.
been
Good,
so
Robert.
on and off for me.
Okay. Very good. And you do have the labs, you do have the files, so you can, and there's some instructions in the files so you can follow. But does this make sense?
It makes sense from the standpoint of that we know the two troublemakers. Now in a real world environment, if we look at this topology like a company build out, then we would generally want to just keep any parts of the company that don't need to have access to those specific things blocked and only allow either if they need HTTP, whether it's their payroll system so that they can log in and say, hey, did I get my pay? I need to do this. And then FTP, whether they're getting their weekly memos or whatever files are going to get transferred.
Yes. Yep, I agree with you. And most companies focus on the perimeter firewall, the firewall that connects you to the outside, just like you do in your house, in my house. We have a wireless access point, and it's focused on securing our local area network from the outside. We're not really worried about our roommates and other people that live in the house. That firewall isn't going to protect us from those people. But I want you to know in large enterprises, like the last time I worked for Hewlett Packard, they had 350,000 people. So you can't focus exclusively on your perimeters. You can't say, I'm just going to protect the company from the outside. Well, you have 350,000 people in the inside. And I can guarantee you, they're not all honest, decent people. So we have to also protect ourselves internally. So the big threat is the internet, the 20 billion devices on the internet today. But a secondary threat is an internal threat. And if you have some sensitive data internally, you still have to protect that. And firewalls are a good use for that.
Zico?
Go ahead.
So basically what you want to do is port filter where you need to and IP filter where you have to.
Yeah.
And then just make sure you apply your ACLs from the perspective of the router.
Thank you. Thank you. And let me say what you said, Cody. IP is a bigger net, everybody. So IP is a big net because IP includes TCP and UDP and all of the ports. So when you are filtering using IP, you're using a bigger net. And when you're filtering using ports, you're using a spear. You're not even using a net. You're using a spear. You're being very precise. And sometimes you want a big net and you use an IP. And sometimes you don't want a big net, you want a small net, or you may want a spear because you're only interested in this one source, in this one destination, in this one service. And that is a spear, that's not even a net. And extended ACL gives you the granularity to do that. Are we saying the same thing, Cody?
Yeah, exactly. Yeah, I just pretty much just boiled it down, yeah.
Okay. So let's do an established. Do you guys remember established? Here, I'm going to come back. Where is it? Right here, established. And we already said we want to allow the traffic back in. So I'm going to move ahead. And I want to go back to an earlier class. You see, we started talking about ACLs in 152, and we talked more about them in 153. And this is a 285 course. We're talking about them again. Packet Tracer Labs. Was it week 3? No. 2. No. 5. I'm looking. Okay, that leaves 6. Hoo-hoo. Okay. So let's do this one lab. And this is just to show you what established does. Okay. So similar topology, everybody. Instead of troublemakers, green, you know, this is the R&D department, top secret. And they don't want people coming into the R&D subnet. Make sense, everybody? And this is something you want to do internally. So remember, firewalls at the perimeter, protecting you from the internet. This is what your wireless access point does. And this is what every company in planet Earth has a firewall to do. Okay, and that's like a top priority. Let's protect ourselves from the billions of people out there. A secondary priority is let's protect ourselves from the people inside. Because as you already know, that is the weakest link. In security, people are the weakest link. And if you're a large company, a very large company, then you know that is a very serious risk. And we want to do what we can to protect ourselves. And this is what we're talking about here is we have an R&D department. They're working on a top secret project, and they want to be able to do their job, go to the outside, do whatever they want to do, but they don't want the outside coming in. So let's take a look at what we did. Okay. Yes, don't forget the last statement is an implicit deny. And here it is. Okay. So what are we saying? We're saying access list 101 permit TCP. Remember, TCP is TCP, not UDP. So we're assuming that they don't have any UDP, which is a terrible assumption, everybody. But established only works with TCP. So we're not talking about a stateful firewall here. We're talking about something between stateless and stateful. And this established only works with TCP. And if you think about it, UDP is connectionless. So we can't really use established with a connectionless protocol because we're saying we initiated this from the inside and we should be able to come back. Well, that only talks about connection-oriented protocols like TCP. So established only works with TCP. You may want to make a note. So we can't use it with UDP. Okay. And we're assuming, you know, the R&D department only wants to use TCP protocols, which is a dangerous assumption, but this is a lab. Okay. And I didn't say deny any, but we know this is implicit. It's there. So I don't have to say it. The very next statement after that is deny IP any. And then I'm applying it to the gig 00 interface. And please notice the direction. The direction is not in, the direction is out. So I don't want people coming in. I don't want people coming in. I want them to be able to get out, but I don't want people to come into the R&D local area network. And this is why the direction is out of the router into the R&D subnet. And this is something that confuses people, the direction. It's always from the interface point of view. Always from the interface. Are you coming in to the interface? Are you going out of the interface? So let's copy and paste. And remember, you know, the very next statement is deny IP any. And paste it. Show access. Here it is. And let's see if people from the outside can get in. So let's see if I can ping one of those R&D computers from the outside. So ping 192.170.1.2. And you guys remember the destination unreachable ICMP? So this device is getting an ICMP error message saying the destination is unreachable because it hit this out port, and that out port said, whoa, wait a second, I'm only allowing TCP back in. Okay. And let's see if I can FTP, because that is very much TCP. So 192.170.1.3 is an R&D server that has an FTP service running on it. So let me see if I can do that from here. FTP 192.170.1.3, and it's going to time out because I'm only allowing the TCP connections that were established from the inside. So now if I was to go to one of those R&D computers and ping, is ping going to work? You look at the ACL and tell me. Can I ping something from the outside?
No, it still shouldn't work.
Because it's only TCP, right? Everybody permit TCP. And ping is ICMP. So if I was to ping 192.168.1.2, it's going to time out. If I was to use DNS, it's going to time out because DNS is UDP request, and I'm only allowing TCP. But let's see if I can FTP or HTTP, because that is TCP. So I'm going to FTP to 192.168.1.3. So I'm going to FTP from green to here, and that worked. And let me see if I can HTTP. That is a TCP protocol 223 192.168.2.3, and that worked. So this is established. And you tell me a couple of things about established. So what do you guys remember about established?
Beyond the obvious that it has to be, you know, bidirectional, meaning that it's going to establish connection out. It'll allow the connection back in.
Very good.
There's a handshake.
Very good. So it only works with connection-oriented protocols. Does established work with UDP?
No, because it's connectionless.
Yep. So you guys need to remember this. You need to remember this. So if you are using a UDP protocol like DNS, which is a super common, right? Everybody, every morning we wake up and we type Facebook. Well, we have to resolve Facebook. Well, that is a UDP datagram to resolve Facebook to an IP. And if these R&D computers were using a DNS from the outside, it wouldn't work, because we are saying only TCP, and established only works with TCP. And maybe I should add this. Maybe I should create a DNS just to show you the DNS request will fail because that is UDP, and we cannot use established with UDP.
What would be the primary purpose of blocking everything except for TCP behind something like this? Because a lot of times
I wouldn't. I'm just showing you, Frank.
Okay. I'm
basically showing you the different tools you have in your toolkit. And I'm not saying all of them make sense.
Okay, and I get that. And sometimes, you know, it helps me to see, you know, if it's a hammer, what can I do with the hammer? Why am I using the hammer?
Very good.
Other
don't use standard ACLs. Okay, I'm just telling you right now, don't, because extended gives you a lot more granularity. So just use a tool that gives you, you know, big net, medium-sized net, small net, and a spear, right?
Yep.
Instead of just using one that gives you a spear, just use one that is more flexible. However, I teach you standard because maybe you get a job and they have some standard ACLs and you have to work with them. You can't say, you know, we didn't cover that in school. I don't know how it works. So you're going to have to use this. And I'm showing you established because maybe someone is using it somewhere and I want to make sure you know what it does. But I would use a stateful firewall, and then everything will work with a stateful firewall. So I'm not limited to TCP. I can use TCP, UDP, ICMP. And here, one limitation of established is it only works with TCP. So when you're choosing your tools, choose the ones that give you most flexibility. And not everything I show you are things you want to use, but things you may have to come across. and you need to deal with. Did I answer your question, Frank?
Yes, you did.
Okay. I would not use established. I would use a stateful firewall, which is what my PC has, your PC has, which is my wireless access point has, your wireless access point has, and they give me the granularity and the flexibility that I want. I'm going to move on. Let's go back to 285 okay. So remember ICMP wiki, and we can go back there. So let's do this lab.
I did want to mention, I'm not sure, but I didn't see the previous lab in the download. I just downloaded it this morning.
Yes, yeah. I pulled that lab from chapter 2. I can dump it in there if you want. So let me do that.
Okay.
So, 152, it was week 6. Yep. And in fact, I can put all of them in there. So just let me do this super fast.
Okay.
Google.
I just wanted, I wasn't sure if that I missed something or if it was in a different file.
So chapter 4, and I'm going to create a folder, and I'm going to call it CIS 152. Chapter 6. You see it? And I'm going to dump all those labs in here because they all deal with ACLs. Okay, they're there, or will very shortly be there, Frank.
Yep,
and they're under. Okay, excellent, very good. So let's go back to where we were. You are most welcome. 285. Yeah, it's right here. Okay. Okay. So using extended ACL, and let's see what prevent ICMP abuse. Okay, so this ACL is to prevent ICMP abuse. Okay, permit ICMP any echo reply. What does the echo reply do? Here, let's do it together. So we have, what does echo reply do? Right here, 0. Come on, guys, it's pretty straightforward.
The ICMP response, it's going to block that.
Yeah, very good. So echo request, echo reply. Okay, so I definitely want to allow an echo reply. Okay, the next one is not supported by packet tracer. What does source quench do?
It's going to reduce the speed or the flow of data.
Very good, the flow of data. Okay, so this is congestion control. This is to deal with congestion. It's like I'm overwhelmed, slow down. And remember, TCP does that by default. TCP does that by default. When a computer gets overwhelmed, it tells the other computer, slow down. And I'm sure you remember the window. It says, don't send me any more data than can fit in this window. And if it stays congested, the window gets smaller and smaller. And then when it's doing better, the window gets bigger and bigger. And then unreachable, okay, notify me, and then deny everything else. Deny ICMP any, and then permit IP any. And this is a great example of where you put the more restrictives first, and then you open it up. So if I had said permit IP any, deny ICMP any, you know, you're never gonna get to that. So I'm denying, I'm being specific, and then I'm relaxing. More restrictive first, and then the more relaxed later on. Any questions on this ACL, everybody? This is just a simple ACL. We're trying to prevent ICMP abuse. Can someone ping from the outside? Well, let's see. So let's copy and paste.
Like if there was an internet connection off of...
Well, remember we have 2 subnets. So look at it from an interface point of view. So if you're not in this interface, you're from the outside. So the fact that you're in the same router and you're behind a different interface, you're still on the outside of this interface. So firewall rules are always from an interface point of view. So if we're dealing, let me see which subnet, interface 000, which is this one here. So gig 001 is the outside because we're applying this to gig 000. Make sense, Frank?
Yes.
And
is there anything connected off of serial 00? I don't think so.
No, there is no. Where does it say serial? It says gig. I may have said
serial. No,
serial.
it's on the packet tracer. It's to the left of the router.
To the left. Hold on. Oh, here?
Yeah. That's why I wasn't sure if that was the serial interface or the...
This is gig. It says gig. You see it?
Yeah, but serial's up there right by it too.
And this is... Oh, yeah. We do have a serial. You're right. No, nothing is connected to the serial. Okay. You're right. Okay.
That's why I wasn't sure if there was an interface outside.
You're absolutely correct. So this router has 2 Ethernet and 2 serial, but we're not using the serial interfaces. So let's copy and paste. Copy, paste. Show access. Okay. Remember, packet tracer doesn't support source quench, so this is why it's commented out. Okay, very good. And then it says HTTP to 1.2, okay, from inside the local area network we're trying to protect. So let me go to PC1 and let me get to this remote. Is this gonna work before we do anything? So this is TCP. It doesn't apply, doesn't apply, doesn't apply, doesn't apply. It does apply, and it says permit IP any. And I'm sure you remember IP includes TCP and UDP. So it's gonna work, right, everybody? Because we're permitting it. So is it gonna work? 192.168.1.2. Okay, it works, good. From LT1, FTP, okay, FTP is gonna work too because FTP is also a TCP and we're allowing IP. So FTP 192.168.1.2, okay, it works, very good. Ping 192 from PC1, ping 192.168.1.2, and it's unreachable. Okay.
And that's getting blocked on the inside
exactly.
of gig 00.
Yeah, because we're only allowing an echo reply, right?
Yes.
And ping 209 from, okay, so we come over here and we ping this guy right here, ping 209.165.201.2, and it's working because echo reply. So did we allow echo request? If we had said allow echo request, then the ping would have worked from PC1. But we didn't allow, and remember the last implicit is deny any. So we're only permitting this, and we're only permitting IP, and IP is IP plus TCP and UDP, but IP doesn't include ICMP. And because we didn't permit echo request, we weren't able to ping from the inside, but we can allow a reply back. Make sense? Again, come back to my table. One of those days, I'm gonna sell this thing. Okay, and you see we have IP, and then above it we have TCP and UDP, and then ICMP is at, even below IP. ICMP is actually, slightly below IP. So when you say allow IP, it doesn't encompass ICMP, and it doesn't encompass ARP, and it doesn't encompass IGMP. It's just IP plus TCP UDP. So that's another note you want to make. IP is IP plus TCP plus UDP, not ICMP and not ARP. Does this make sense?
Yes, it does.
Okay. Again, one more time. ACLs are challenging because there's just a lot of details. But this is one challenge you want to conquer. This is one challenge you want to conquer. And it really isn't hard. Time consuming, yes. You're going to have to spend some quality time going over these labs step by step. And I think if you just start from lab 1, from scenario 1, and you work your way down at your own pace and make sure everyone makes sense before you move on to the next one. Make sure that you understand. I think by the time you get to the last lab, you'll feel much more comfortable with it. And then you can do the assignment a lot easier because it makes sense now. Okay, I'm going to move on. And remember, we're not going to finish this entire chapter today. So let's go back to 285, packet tracer labs. Okay, so we have stateful and stateless. So let's do 2 more labs, everybody, and we will stop, which is basically 4. So let's just do the 4 labs and we will draw the line right here. And let's make sure they make sense. So this, we have 4-1, 4-2, 4-3, and 4-X. And the 4-X is the packet tracer for all of the 4 labs. So this is my numbering mode because I didn't want to have to create 4 identical packet tracer files. So let's see, the first one is stateless. So who wants to tell me what is the big difference between stateless and stateful? Okay, you don't have to tell me.
Stateless passively filters off of destination and source, where stateful is actively scanning packets.
Very good, very good. Yeah. Yes, I would use a different explanation, but I hear what you said, Joey, and you are correct.
It's stateless is connection orientated. Is that what I'm? No, it's opposite.
No. Yeah, it is opposite. The way I like to look at it is stateless relies exclusively on static ACLs. Everybody, the stuff you typed in. So those are the static ACLs, and stateless just looks at those static ACLs and say, you know, permit, deny. Stateful has the static ACLs and has dynamic ACLs. And the dynamic ACLs are based on what did you initiate from the inside. Good, everybody? So for me, this is an easy way of remembering the difference. Stateless, strictly static. Stateful, static plus dynamic. And dynamic are the sessions. And I want to show you this today. So we'll do this today, and I will show you. And let's start here. So let's start with stateless. Stateless firewalls filter all inbound and outbound traffic based on the static rules. Okay, no dynamic rules, static rules. Okay, and we do need the security module. I think we talked about this a little bit last week, so let's go ahead. Oh, we don't need this for stateless. We need it for stateful. So if I was to come over here and do show version, and IP base is included, very good. And security, we need to enable this. However, we don't really need it for stateless because stateless is built into IP base. So all we need for stateless is IP base, and we have everything we need. Okay. And everything, right now, we don't have any firewall rules. So access, nothing. Cool, everybody? So there are no rules. So we're not denying anybody access to anything because we don't have any ACL rules. Okay, very good. So on R1, okay, inside rule, the traffic you are permitting from the inside to the outside. Outside rule, the traffic you are permitting from the outside back inside. Okay, and currently none. And the rule order is very important. We already covered this. And the very last statement is an implicit deny. We've covered this. Okay, so let's take a look at the ACL. IP access list extended inside. So this is named. And this is what you want to, if you're creating your own ACL, please don't use standard and don't use numbered. Just use extended and named. Okay. Inside permit TCP any www, permit TCP any 443, permit TCP FTP. So I'm basically saying from the inside for PC1 and server 1, and this is home, and this is the internet, that's all I want to allow. And we can argue if this makes sense or not. Don't you really need DNS, etc.? We're not having that conversation. We're just saying, technically, this is all we want the internal computers to be able to do. They're only using TCP. We only want to give them web, HTTP, and HTTPS, and we only want to give them FTP. And then deny IP any. I didn't even have to put this in here, right, everybody, because it is implicit. And this is inside in. This is coming into gig 00, and interface outside. And the outside is deny IP any. Good. This is not what you have at home, but close. We're basically saying we don't want anything from the outside coming in. You see it? Outside, deny IP any. Nothing can come in from the outside. However, we're only limiting HTTP, HTTPS, and FTP from the inside. So let's copy and paste. Copy. Does this make sense, everybody? It's fairly simple. This is a very simple ACL. We're saying only allow this from the inside and don't allow anything from the outside. Okay. And if I was to do show access, so we have inside, we have outside. And by now you all know the golden rules. It's a long list of golden rules. One of them is one ACL per interface per direction. Okay, good. So let's see. What did we just do? From PC1, ping to the outside, did we permit ping everybody? Did we permit ICMP?
No, and you have the deny any, so that's going to get blocked.
So it's going to fail, right, everybody? If we wanted to permit ICMP, and then remember, we have many variations of ICMP, and this is why I want you to spend a few minutes with ICMP wiki. But we're not allowing any ICMP, so it's going to fail. So if I was to come over here and ping the outside, it's going to hit that wall, 172.30.1150. Okay, and destination host unreachable, very good. And the second one is from PC1 FTP 172 FTP from PC1 FTP 172.150. Okay, is this gonna work? This is a great question. I love it. Remember, this is a static. This is a stateless firewall. So
they'll fail because you're not allowing the connections back in.
Very good. You got it, Frank. Very nice job. Everybody, we're going to be able to get to the outside, but then coming back, it's going to hit the wall because remember, it says deny IP any, and this is a stateless firewall. And we said the stateless firewall looks at the static rules, and these are the static rules. And according to the static rule, nope, you can't come in. So let's try it. So we're going to FTP. So before we hit the wall right here, in fact, let me show you. So let's redo the ping, show you where we hit the wall. This is the beauty of this emulation mode. And we hit the wall. You see the red? Okay, very good. So let's FTP. And let me simulate. And let's see what's going to happen. And Frank is right, but I want to show it to you. So we're going to go to gig. And we have an ACL here, and the ACL said FTP. This is ARP. Very good. So we need to do the ARP thing before we can do the FTP. And here we go. This is our FTP. And it's fine. Saying, yep, you're good. Go to the FTP server. And now we need to come back in. And this is a stateless stateless firewall, the stateless firewall goes strictly by the static rule, and the static rule said nothing from the outside. And it stopped right there. And that's why I did this lab, just to show you the problem with a stateless firewall, the limitations. I shouldn't say a problem, because in some scenarios, that's exactly what you want, but the limitations. And then what's the next one? HTTP, it's the same thing. Okay, so if I was to come down here, go to this server, and HTTP 172.30.1.150, same exact thing. So I'm gonna go, it's gonna allow me out. I'm doing the ARP thing. It's gonna allow me out. And in the way back, it said, sorry, nothing is allowed in. Well, nothing is allowed in includes all the stuff that was initiated from the inside, because it is a stateless firewall. Questions? Does everyone see the limitations of a stateless firewall?
Yep.
Okay. And that's not what you have at home. This is not what you have on your PC or in your wireless access point. However, if you don't use that security module that is available for some of the routers, that's all you're limited to. So iOS, okay, iOS limits you to stateless unless you enable that security module, which we will do next. So I'm going to move forward, and I'm going to do the 4.2. Same exact lab, and 4.2. Okay, and we're using stateful. And remember this for your job interviews, everybody, because firewalls are a common topic on job interviews, because they tell the interviewer a lot about how deep your understanding is. Stateful firewalls filter all inbound and outbound traffic based on static rules, the rules that you created, and inside initiated sessions, the dynamic ACLs. So static and dynamic. And I want to show you that. But first, we have to enable this package. So let me do it really quick. And you have the instructions to do it. License, boot, module, CTS, yes. And I have to reload. And now it's running. And I'm going to show you that. And show version. And you guys see it? So we have the security K9 module enabled. And it says evaluation because this is something you have to pay for. This is not freebie, but for what we do, it's enough. But if this was a production router and you want to use security K9 and you didn't buy it initially, you have to pay for it, and then it would say permanent. You can always evaluate for free, which is what we're doing here, but you have to pay Cisco for that. So let's take a look, everybody. Okay. Okay. So to Cody, this may answer a question you asked last week, and we will dive deeper into it. So the security K9 module gave us this command called IP inspect, and IP inspect is a stateful rule. Good, everybody? It's a stateful rule. So it's going to create that session. So that's what you're going to see right now. IP inspect name firewall rule, and you can call it whatever you want. It's just a name. And allow ICMP, allow TCP, allow UDP, and I don't have to say deny any, it's always an implicit. Okay, and then go ahead and apply this rule on the inside, and then look on the outside, deny IP any. So the static rule coming back in is deny any. However, we are using a stateful rule, this IP inspect, which is a part of the security K9 module. So I'm going to copy and paste, and I enabled ICMP, I enabled TCP, I enabled UTP. That's pretty good. So this is similar to your home wireless access point. That's probably what you have inside your home wireless access point, or something very similar. And the show access is only going to show me the static. However, I can do show run, and I can see the rest of it. So let's test it. So this is stateful. And stateful is we're still relying on the static. And then every time we initiate something internally, we create a dynamic rule. So we have two tables, a static table and a dynamic table. And the static is static, and the dynamic, changes. Because, once you terminate that TCP session, it's no longer a session. So let's test. So from PC1, let's ping the outside. And it should work because it is stateful. Ping 172.30.1.150. Okay, I have too many numbers in here. 150. Okay, better. And it's going to fail the first time like it always does, and it's going to work now. Everybody? So this is very similar to what we did before, except this time it is stateful. Okay, and let's see if we have a session. Not here. Show IP inspect sessions, and we don't have any session because it's TCMP. It's not a TCP that creates a session, but it allowed it back in. Okay, and HTTP, and that's going to work because we're allowing TCP, and it is a stateful firewall 172.30.1.150, and that worked good. And FTP is going to work. I'm going to do it really quickly because that's TCP, and we allowed that. FTP 192.30.1.150. How about 172 instead of 192? User error. And it worked. So this is all good. Okay. How about if we try to come into the inside from the outside? So let's go back to the rules. But let me show you the sessions. Let me show you the sessions. Do you guys see the session? This is the dynamic rule. So we're saying we have session, we have a number, and from 10.003, and this is the source port number. I will come back to this in a second. And we are going to 172.30.1.150, and this is the destination port number. So 21 is the port number for which service, everybody? 21. FTP. And what do you call IP address colon port number? So we have IP. Say it again.
A socket.
A socket. Thank you very much. So we have incoming socket and a source socket and a destination socket. And why is the port number 1027 for the source port number?
That's dynamic, right?
That's very good. You got it, Corey. It's dynamic or ephemeral. And ephemeral starts with 1024. So maybe 1024, 25, 26 were used. So it grabbed the next available one, 1027. And I said you can never rely on what that source port number is going to be because it's dynamic. It's whatever is available next. But you know it's going to be greater than 1023. And then from the outside, it's not going to work because from the outside, we only have the static rules. And ping 10.0.0.3 and destination unreachable, and FTP 10.0.0.4. and it's going to time out. So is it clear the difference between stateful and stateless?
Yes.
Okay. Everybody? Stateful, stateless, and to use stateless with the Cisco products, you have to enable their Security K9 package. Stateful too. So the third one. Okay, let's do one more and we'll stop. So this is the last one we'll do today. And on Monday, I want to start by reviewing the 4, and then we'll do 5 and 6. So let's do the last lab for today. And let's see what we're trying to do here. Same topology. Stateful firewall. Okay, we already know that. We need to enable the Security K9. Okay, I will do that. But let's see what we did. So we said IP inspect name, firewall rule TCP. So I'm allowing all TCP, not UDP, not ICMP. Do you guys remember that? So TCP is stateful. I didn't mention UDP or ICMP like I did before. And then I created a static inside rule, and I'm only allowing www 443 and FTP, 80, 443, and 21. So this is a bigger net, everybody, because this says TCP, and this is a narrower TCP rule. So TCP is all the TCP protocols, which is a long list of protocols. But I didn't want to allow all of them. I only wanted to be more precise. So this firewall TCP said anything that is initiated from the inside using TCP can come back in. And that doesn't include ICMP or UDP. And then the second inside rule said, wait a second, I don't really want all TCP. I only want these 3 specific protocols. And then the outside rule is still the same. So let's copy and paste. First, I have to license. Oh, is it enabled? No, it's not enabled. Oh. Yes, and we do have to reload. And I damaged this by mistake. Can I fix it? Okay, here we go. So let me copy and paste. So I have 2 rules. This is the difference here, is I have 2 rules from the inside. A bigger net and a smaller net. And the smaller net is going to win. So why do I have the first TCP rule? Everybody? So let's talk about this. I have 2. What does this buy me? IP inspect name, firewall rule TCP. What does this buy me?
All TCP traffic will be filtered or inspected.
Okay, very good. What else? You're right. What else? IP inspect. It enables that traffic to come back in, right, everybody? It's
right.
stateful. And then let's look at the other inside. Only allow 80, 443, and 21. And then I'm saying you can only use these 3 protocols, not all TCP. So let's copy and paste. Okay. Can I ping to the outside? I'm asking you. Is ping gonna work? It worked in the previous lab. Look at the inside.
By ICMP in your inspect rule, I
Yep.
think.
It's ICMP. Am I allowing ICMP back in or even out? I'm not allowing it out or back in, so it's gonna fail. Okay, because I'm not allowing it out or in. It's hitting the wall on the inside interface. Can I use FTP? Yeah, I can use FTP because I'm saying this is state full and you can use FTP. So FTP should work. We should be able to get out and come back in. Yep. HTTP and HTTPS is going to work. And I can't do anything from the outside because from the outside, do I have a session? Let me see. Show IP inspect session. Yep, that's the session. We have source socket and destination socket. And now we're using a dynamic port of 1025, fine. And from the outside, we can't do anything because we're gonna hit this outside rule that says, okay. What does the outside rule say? Outside. Do I have any ACEs underneath? I don't have anything underneath, but we have the implicit deny, right, everybody? So last time I explicitly said deny IP any. This time I just created an outside rule. I left it blank, which means the only thing in it is that implicit deny IP any. So let's see. Pinging 10.0.0.3. And that's gonna fail. It's hitting the wall on the outside. And if I was to do FTP, it's also gonna fail. And if we are to simulate, you can see it's dying right here. It's dying on the outside interface. Questions?
Zico?
So the only thing that we've done today new, give me a second, Cody, is we are using this IP inspect command from the Security K9 module. That's the only new thing we've done today. Everything else we've done before. And this is important because it gave us that that stateful capability. But that's the only thing we learned today. Everything else we've done before and is a review, and it's a very important review. And the only thing we've added today is changing that router from a stateless to a stateful by using the IP inspect command from the Security K9 module. Cody.
I just wanted to clarify. So when you make your IP inspect rules, so
Yes.
you say IP inspect, TCP, UDP, all that stuff, I think it's super important to make sure you apply it in the right direction, because if you say IP inspect, inspection list name, and then in on your WAN interface, it's
Yes.
probably going to be useless.
Yes.
Right? You want to make sure you say out.
Very
so
good.
Your internal screen.
Very good.
Screen.
Thank you, Cody. Thank you very, very much, Cody. So direction matters, everybody. So the direction does matter, you know, which interface and which direction. So you have to apply it to the right interface and you have to apply it in the right direction. And what makes sense is deny or permit as soon as you can. Don't wait until the traffic gets, you know, to the other side of planet Earth before you deny it. That's a waste. So do it as early as you can. And extended gives you that capability because you can filter on source and destination. And I want to show you one last thing. We're done for today, but I want to show you what the options are for that IP inspect. Conft IP inspect name, whatever you want to call it, Zico ? And this is what packet tracer enables. So you can do HTTP, you can do ICMP, you can do TCP, you can do UDP, and you can do Telnet. And some of you are saying, Zico, wait a second, you know, if we enable TCP, isn't that the same thing as enabling Telnet and HTTP? And the answer is yes, but these are only two TCP services, and you can just stop at TCP and allow all TCP services, or you can go one step further and say, I only want to allow HTTP TCP or Telnet TCP. So how granular do you want to be? So these are the options in Packet Tracer for the IP inspect command. Questions?
I just had a quick question for you. It seems like it might be a good idea to use a combination of stateless and stateful.
Yes, yes, yes. And that's exactly what we did, Corey. Sorry, I didn't mean to cut you off. That's exactly what we did. So let's look here. Okay, IP inspect name firewall rule TCP. This is a stateful rule. And then immediately below it, IP access list extended inside, that is a stateless rule. So even, you know, for incoming data, right here, look everybody, IP interface gig 00, I'm using stateful and stateless. So I'm agreeing with you, Cody, and I'm saying we did exactly that in this scenario. Yep.
Your stateless basically establishes a baseline of security.
Yeah. Thank you. Yep, makes sense. And then the order really makes huge difference right here. For example, you know, ask yourself, what would have happened if I put IP inspect before IP access group? Well, you're changing the order. Changing the order mixes the cards, and the result is going to be different. And when you're playing, do it. You know, when you're experimenting on your own, I want you to change the order of those two lines and see what difference it makes, because it's going to make a difference. Order does matter. Questions? So I know you have to read chapter 3 in Net Academy, and you have to do the labs. And I don't think there's anything complicated there. What else do you want to do between now and Monday? What other task do you have before Tuesday of next week?
I need to review 152 stuff. That's me personally, though.
Okay. How about the rest of you? What else do you want to do before next Tuesday? Anybody?
Are you talking about for the rest of this class?
I'm talking about this class. I'm talking about, yeah, this CS 285. Okay.
I want to do the packet tracers to get my hands on it.
Do the labs. Okay, do yourself a favor, because on Tuesday we're going to add to this knowledge. And if this doesn't make sense, then why would the rest of it make sense? And if I lost you half an hour ago, you're probably bored to death right now. If I lost you an hour ago, you're probably bored to death right now. Okay. So we can only move forward if the stuff we've already covered makes sense. Or it's not going to be a very good use of your time. It's going to be very frustrating for you. So please, you know, conquer what we've covered already. And that will give us the base that we need to move forward. And I'm going to, just to show you, on Tuesday, I'm going to redo the 4. I'm not going to do 1, 2, and 3. And I want you to do 1, 2, 3, and 4. But I will redo 4, and then we'll do 5 and 6 together. And that's it for Tuesday. And then we will talk about IDS, IPS on Thursday, and that would be an hour and a half, maybe 2 hours most. I'm done. So if you have questions, go ahead. Going once. It's gorgeous outside. My dog is staring at me. I'm going to take her to the forest. You have a lovely day, everybody. Have a great weekend. I look forward to seeing you next week.
Thank you. Have a good one.
Thank you. Bye, Zico.
Bye, Zico.
Busy.
Goodbye.